Okay, so the third scenario I wanted you to be aware of is when you might have an equation that contains a whole number or term in that equation. And the main thing I want to point out in that scenario is that when you are multiplying both sides of the equation by the LCD, you would need to multiply that to all parts of your equation. So not just the parts with denominators, but with every single term in your equation, including the terms that are whole. And that's just because of the rule of property of equality that says if you're going to multiply something to one side of the equation, you have to multiply it to the other side. That's rule number one. Rule number two is you have to multiply it to the whole entire other side. You can't just pick and choose what parts you're going to multiply by, because then each of these individual expressions will not be changing in the same amount, and then this equality will no longer hold true. So I just wanted to kind of remind you of that. So in this particular example, our LCD is pretty simple because I just have two denominators, both of which are unique. Like there's no common factors. Both of these are considered to be remaining factors. So I just multiply them to each other to figure out the lowest common denominator. So that's what I'm going to be multiplying to both sides of this equation is just 4x over 1. Because remember, you want to multiply by your LCD over 1 so that you're only really multiplying it to the numerator. So then if I write out what I have, like if I distribute my 4x to every term, then I end up with these three expressions. So with the first expression, I notice I can divide out a common factor of x from the 4x and then the x in the denominator here. And I'm just left with 4 times the quantity 2x plus 3. With this whole number part, I noticed there was no denominator, so nothing cancels. I just multiply the 4x to the 1. And then with the last part, I can divide out the 4's. And so I just multiply the 5x times the x. So then what I'm left with is 4 times the quantity 2x plus 3 on the left side, 4x times 1 on the right side, and then plus 5x squared, because I had to multiply an x to another x. So again, just like with the last example, this is where I have to kind of pause and recognize this equation has now turned into a quadratic equation. That is because one of my x's is now squared. So this is where I sort of change course, and I now try to get one side of my equation equal to 0. And I personally like to keep the x squared numbers positive. So what I'm going to do, well, first I'm going to distribute my 4 over here so that I can see what terms I'm working with. So this part turns into 8x, and then this and that turns into 12. And then I have 4x plus 5x squared on the right. So I'm going to start by subtracting the 8x to both sides. I want to get all of the things on this side, and I want to get 0 on the left. So when I subtract 8x from 8x, I get 0. When I subtract 8x from 4x, I get negative 4x. And then I want to subtract the 12 from both sides so that I can get my 0 on one side. But I'm going to write this where I have my x squared term first, and that was positive. I'm going to write my x term second, and that was negative. And then I'm going to write my constant term last, and that was also negative. So I have a positive 5x squared, a negative 4x, and a negative 12. So this again is set up so that I can either factor and set each factor to 0 or use the quadratic formula. I am going to try and factor this one because to me that's easier than the quadratic formula if it works. So I'm going to set it up my little box and see if I can make this work. So for 5x squared, I can only use 5x and x. But for 12, I can either use 4 and 3, 2 and 6, or 12 and 1. So I'm going to kind of do some guessing and checking with those possible combinations. So I think I'm going to try the 2 and 6 first. And I'm going to try having the 2 go opposite the 5. Yeah. Okay, that will work. So I'm going to make it so that it's -2 being multiplied here and then +6 down here. That would turn this box into a -10x because I multiply the -2 with this 5. And then this box would just be 6x because I multiplied those. And so I notice if I add those together, I do in fact get that -4 that I needed to have. So these will be my factors, 5x plus 6 and then x minus 2. So then my equation turns into this. I still have my 0 on the left, but now I can rewrite my 5x squared minus 4x minus 12 as 5x plus 6 times x minus 2. So since I have a product and that product is equaling 0, I can figure out what values of x would make it 0 by just setting each factor equal to 0 and then solving for x. So one solution would be when x is -6/5. Another solution would be when x is 2. Now before I lock those in, I'm going to go back to the original setup of this equation and just make sure I don't have any like restricted values that would conflict with my solutions. I noticed in the original problem, the only time I had a variable in the denominator was when I had x in the denominator for that first fraction. So the only restriction in this problem is 0, which does not conflict with my solutions. So I do have, both of these are valid solutions. They're solutions not only to this quadratic, but they also would act as solutions to this original rational equation as well.